Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. This is our data management part 2. As we discussed last week in data management part 1, we discussed some definition and the concepts about data. We talked about data collection plan in details, and we explained what's data collection tools, and we gave some hints about data analysis and presentation. Today we will continue our second presentation related to data management. We're talking today about sampling and population. So what's population? Population is the total aggregate or group of cases that meet a designed set of criteria for inclusion in a study group. So the population is the total population I want to study. Example of total population, all physicians. I'm going to study what the physicians are doing inside a healthcare facility. So the physicians are our main total population. Another example is all patients who have expired at a particular hospital. All people died in one hospital are my target to study. So this is my population. Utilization review nurses under 30 years of age. So I will study all the nurses under 30 years of age. So all those nurses are my total population. What about sampling? Sampling is a process used in a statistical analysis in which a predetermined number of observations are taken from a larger population. Sampling means I'll take a few number of the total population to study them, and so I can or not generalize the results over the total population. So this is the definition of population and of sampling. Let's discuss sampling in details. Sampling is probably the most important thing you can do to reduce the amount and time and resources spent for data collection. If you are going to study all physicians, you will consume a lot of time and you need a lot of resources, people, paper or IT, money, extra time, and so on over time. So you need a lot of resources to study them all. But if you take a sample of all physicians and study them, you can generalize according to your sampling technique. You can generalize the result over the all physician as you did your study upon them all. So sampling will save your time and save your resources. Okay. So Ishikawa Classic Work Guide to Quality in 1982 identified 4 conditions for developing a sampling plan. If you're going to do a sampling plan, you have to take care about accuracy, reliability, speed, and economy. We have something named sampling bias. Maybe we'll face it now while we are talking about this presentation. So you have to know what's sampling bias. Sampling bias occurs when some members of the population are systematically more likely to be or not selected in a sample than others. So if we are studying some population and we are intended or even by mistake took some people and leave others, this is a sample bias. In statistics, sample bias is a bias in which a sample is collected in such a way that some members of the intended population have a lower or higher sampling probability than others. If a group of the population you are studying have a higher or lower probability to be selected inside the sample, it's a sampling bias. An example for sampling bias and types of them, we have selection bias and we have response or result bias. Selection bias when you are taking some people and leaving others. Example, phoning a people for survey exclude the homeless or those don't have a phone. You want to do a survey over some people. When you are calling some people only at home, discussing them and get information from them, you have a sample bias for selection because you did not select the people who do not have a phone. And you did not talk with you, the homeless people. Of course, they don't have a phone. So you have a selection bias. You selected some people from the whole population, but you are targeted only to some people in your selection. What about the response bias or the result bias? Example here, worded a question in a way that influenced the response. Example, disposable diapers make up less than 2% of landfill or landfill trash, while beverage contain third class male and yard waste are about 21% of the landfill trash. Here you are pushing the people to tell you the response. You are preparing the result in your mind before making the sampling itself, sampling technique. Another simple example here, this is the result bias or response bias. Look at that girl, when she got an A positive mark, she said that, thank you very much, it's because of my effort, because I did it. Yes, I'm good. But when she got F grade, she started to blame other people, external factors. Like she's blaming the schools, the teachers, the parents, the environment, anything else. So this is the types of bias. What are the types of sampling technique? We have probability sampling technique and non-probability sampling technique. Probability sampling technique means simply every single one inside the population have the probability to be selected while I'm taking a sample. Example, if I'm studying the behavior of the nurses inside a facility, before starting to take my sample, I have to put in my mind that every single nurse could be selected, young or old, tall or young, or short, sorry, tall or short, and so on. Every single one of them could be selected inside the sampling size. What are the types of the probability sampling? We have simple random sample, systematic random sampling, we have stratified random sampling, and we have the cluster random sampling. The other type is non-probability sampling. Here, not each single staff or single one inside the population have an equal chance to be selected. Here, my selection is targeted or skewed to some population rather than some population. I will give you the examples after we will know what types, what's the kinds of non-probability. We have convenience sampling, quota sampling, judgment or purposive sampling, snowball sampling, and expert sampling or Delphi technique. We will explain here right now. We will start with the probability. Probability means every single element inside the population have an equal or random chance to be selected. Okay, so this is the definition of the probability. Types are: number one, simple random sample. That means all subjects in the population have an equal chance of being chosen. Example, if we're trying to pull a name out of a hat containing all names, is a simple random sample. Let's say that we are 50 and we want to select 3 of us to go to meet the leadership group. How can we select them? We will put our 50 names inside a hat, we will mix them very well, then ask anyone to come and select any 3 names. So now every single one of the 50 have an equal chance to be selected. So the 3 have to represent the population of the 50 of us. So pulling names of a hat containing all names is a simple random sample. What about the second type, which is systematic random sample? After we selecting the first case randomly, we will choose every TH element. Example, picking every third name of a list of possible names is an example of systematic random sample. I'll give you example here. If we have 600 medical records and we want to select only 60 of them to study, how? If we started with the first 60, we have a bias. If we started with the middle 60 or the last 60, we have a bias. So what we have to do, we have to select the first medical record by randomly. Like say we will start from medical record number 7, number 10, number 1, number 2, number 50. So every single medical record now have the chance to be selected randomly. Then we will select every TH. So here I told you that we will start with, let's say with number 10, or starting from number 5, sorry, medical record number 5. then we will select every 10th medical record. So I will select number 5, then I will select number 15, then I will select number 25, and so on until we reach 60 medical record. I hope it's clear. Here it's very clear. If we have a population from 1 to 12, so I will select number 1 or 2 or 3 randomly. So here I selected number 2. Then after 2, I will select every TH. Here I selected every third. So randomly I choose number 2, then every third. Skip 1, which is 3 and 4, and take number 3, which is number 5. Skip 1, 2, and take number 8. Skip 1, 2, get number 11. So now I have 4 staff or 4 elements. Those 4 elements are representative of the 12 total population. And I can reflect the result or generalize the result over the whole 12 population. This is the systematic random sample. The third one in the probability is the stratified random sampling. Stratified means we will divide the total population into strata. Strata means homogeneous subpopulation. People looks like each other, and I will take them to study as a strata of the total population. So after the population have been divided into strata, each member of the strata have an equal chance to be selected. So again, if every single one have a chance to be selected, it's random sample. But here I divided them into strata so I can divide them. Example here, if I have a population containing males, females, and kids, and if I put them like this and I take a sample of them, maybe all of them will become males, maybe all of them become females, maybe all the sample I'm taking are kids. So what I'm going to do, I will separate them at first to males alone, females alone, kids alone, then take my sample from kids, another sample from females, another sample for males. It would be a representative for the total population. Here is the example. As you see here, every single person of this population have the chance to be selected. So I have to divide them at start to strata, males, females, kids. Then I will take a sample of this one, sample of this one, and sample of this one. This is called stratified random sampling. There is another special example of the stratified random sample called the stratified proportional random sample. For example, if we know that well baby visit is 50% of the clinic business, 50% of the people come to us in the clinic is for well baby, and 30% are coming for follow-up, and 20% coming for unscheduled visit. How can I will take my sampling now? I will take the sample according to the percentage of the people coming. So from the 50% coming, I will take 50 element, and from the 30% I will take 30%, and from the 20% of the people I will take 20%. So my sample is according to the total population division. Here is the example to make it very simple to you. If I have the total population here of 40 females and 60 males, if you're going to take a sample of them, take the sample according to their number. For example, the 40 female, I will take 4 females only. Okay, the sample will be 4 of 40. Can you solve it now? So from the 60 males, how many males I will select in my sample? Can you answer? I'll give you 10 seconds. Of course, it will be 6. So 40 of 4, 40, I will take only 4 of them, and 60, I will take 6. So we will call this one, it's stratified because we divided them into males and females. And why it's proportional? Because I selected my population according to my sample, according to the population. 4 of 40 female, 6 of 60 male. The last one in the random sample is the cluster sampling. Cluster, this method requires the population to be divided into clusters. I will divide people into clusters, then I will select the sample from the total population. Here, as you see that we divided people into clusters, then I will take one sample from the first cluster and another sample of the second cluster. Simply here, if we have different four groups of school, four groups of hostel, divided in a geographical distribution, I cannot go to study these people, then go to study these people, then go to study those people or those facilities, then go to study them. No, I will take only sample from one cluster and another sample of the other cluster. Then I can right now generalize my results over the whole population. This is called cluster sampling. Now the other type is the non-probability. Non-probability means every single elements inside the population have no equal chance to be selected. So we have here intention. We are studying it for simple or for specific reasons. Non-probability sampling provide no way of estimating the probability that each element will be included in the sample. When its approach is used, the result will be representative of the sample only and cannot be generalized all over the total population. So now, non-probability, when I'm studying sample, I can generalize the result over the sample, not over the population. But in the probability sampling, the result I have from the sample, I can generalize it over the whole population. This is the difference between probability and probability sampling. What are types of non-probability sampling? Number one, we have convenience sampling. This approach allows the use of any available group subjects because of the lack of randomization in the sampling method. The subject may be atypical in some way, like sending a survey to a list of members of an elder organization may not reflect the option or the opinion of other elders. For instance, convenience sampling may include all patients at one organization who are undergoing a certain procedure over 12 months. Another example, studying sickle cell people cannot generalize the result of sickle cell anemia people over the total population, but I can generalize it over sickle cell anemia people only. Again, studying patient in ER 1 day per week because I cannot study all the patient in ER all over the time, but I cannot generalize the result all over the year, for example, or all over the people come to ER in a month. So convenience now means reasonable. It's acceptable because I cannot study all population. So I'm studying people over 60 years old. I'm studying sickle cell anemia. I'm studying diabetic patients. So you cannot generalize the result of a study of diabetic people over the total healthy people. You have to generalize it only diabetic people. This is the example of convenience. We have all those people. I cannot select it all, but convenience is to take a kid, woman, and man. So if I took them, my selection is only through this white circle. So it's intended to do because I cannot take all of this. So this is a convenience sampling, and the example is sickle or diabetes mellitus people. Number two, snowball. As you know that snowball, as it's go down, it gets more bigger and bigger. So what snowball type? It's a type of convenience sampling. This involves subject suggesting or recommending others. I cannot reach all the population, but I can reach one of them. The one I can reach, he will tell me about another 2 or 3 or 4. Then those people, I'll go to them, ask them, they will tell me about another people, and so on until my sample is getting bigger. This type of sampling is used if the subjects are difficult to identify but are known to others. They know each other, but I don't know them all. Because of an informal network, they have an informal network. Selection bias may be likely to be present because those who agree to participate may be different from that people don't agree. For example, if I found 2 TB patients and I asked someone to tell me about other TB people, he can tell me, yes, I'm going to do. But the second one, he will tell me, no, I don't like, I will not help you. Okay? Sending a survey to a list of members of an organization that represent nursing is one example of this one. If I'm doing survey for nurses, it's a snowball Because I send the survey to one nurse, she will send it to another nurses, but take care, still I'm studying nurses only. So I cannot generalize it on over nurses or even over the total population inside the healthcare facility. And the TB is the most important example here. Look at here. I reached this one. I asked him, he told me about 2. I go to the 2, I asked them, every one of them gave me, for example, another 3, and so on until I reached a good idea about those type of people. Another type of non-probability sampling is the purposive or judgment sampling. And here this method select a particular group or groups based on certain criteria. I put some intention in my mind to select and to study those people. This method is subjective, and the researcher uses his or her judgment to decide who's representative for his population. He want to study this population, he decided what kind of people that represent my population. Using a group of nurses because the researcher feels, take care about feels or thinks or thought that they represent a cross section of women would be an example of this one. If I said that if I'm studying the behavior of nurses and I will reflect it on all females, no, it's not. I can reflect it on some of nurses, yes, but not all females. If you know this one, is as they said that the time machine, when some people will pick only the most clever or the tall or the strong or the people know in IT or the physician, they are intended to select only some kind of people. But as you see here, all other want to be selected, but they are not. He selected on purpose, on a judgment. Another type of the non-probability sampling is the expert sampling, what we are calling it the Delphi method or Delphi technique. This type of purpose sample that involve selecting expert. My sample is experts only in a given area because of their access to the information relevant to the study. Expert sampling is used Delphi technique, as we said, in which several rounds of questionnaire I will send to those experts, but take care, those experts are supposed to be in a different geographical distribution. For example, one of them in the United States, one in London, one in Canada, one in France, one in Egypt, one in Kingdom of Saudi Arabia. You will send a questionnaire to them. They will give you the answer. You will study numbers and you collect data, send them back to them. If the aim is to reach a consensus of them. They have to tell you that a consensus, that we agree upon the type of medication, the vaccination, for example, the opinion about something. Okay, and send out again, after sending the questionnaire, sending them to again with data analysis. So the aim is to achieve fairly rapid group consensus. A conference planning team is an example. Planning team is an example of the Delphi method. So this is the Delphi method. I have an expert here, expert 1, 2, 3, 4. I'm sending something to them, getting feedback or getting consensus from them. It's called expert sampling or Delphi method or Delphi technique. And we have another type of the non-probability sampling is the quota sampling. Quota means the researcher pre-specifies characteristic of the sample and determine the proportion of the element needed for various segments of the population. So he selected some people, he determined some people, and also he studied or he detects what elements he needs from those population. Example here is to study 5% or 30 cases from the total population. So I determined from the start that I will take only 5%. Example here is the closed record review, that we will take 5% of the discharge in the last 3 months and we will study them. As you see here, not every single one in those population have an equal chance to be selected, but I selected only people over 50 years old. It's a quota. I took a quota. Only people over 50 years old and they are males. Now we finished the type of sampling technique. What about the sample size? Here, the most important thing you have to know, depending on those factors, a small or large sample size may be appropriate. Yes, however, with the exception of case studies, the larger the sample, the more the valid and the accurate the study. For example, if we have 100 population and I asked you to study them, the more the number you are taking in your sample, the more the representative of the population or the result, and you can generalize it over the total population. Example, if you study 20% of the 100 and you study 60% of the people of those 100, of course, the result of the 60% or the 60 individual of the 100 is much better than the 25. So the larger the sample, the more the valid and accuracy of the results of the study. So what's validity? Validity is the degree to which an instrument measure that is intended to measure. Validity means we will use the instrument or machine to do what's intended to do. For example, a thermometer, we are using it to check temperature, but never we use it to measure a height. So the validity is the truth of the measure. Okay? What about the reliability? Reliability is the extent to which an experiment, test, or measuring procedure, it will give the same result on repeated trials. Again, what's reliability? Repeated measures will give the same results. Example, if I'm using some weigher to weight some people, if the weight is 100 pounds or 110 pounds at 1 minute, when I'm repeating it after a couple of minutes, it will give me the weight become 160 pounds. It's not reliable, it's unreliable. So if we are using a sphygmomanometer to check the blood pressure for a patient, if I checked right now, it's 120/80, and I'm checking within 2 minutes, 120/80, again 121/81 or 82, we call this one reliable. But if I'm checking it right now, 120/80, and within 2 minutes I checked it, it's 160/100, it's unreliable unless there is no clinical condition on the patient. So the reliability is the consistency of the measurement. Let's go for a very important issue for data, which is the statistical analysis. Measures of central tendency and the measures of dispersion or spread. What are the measures of central tendency? The aim is we are trying to check the relationship between the numbers or figures to a middle value. Okay, so the fluctuation of the items or the data around a middle value, or the tendency that they are trying to come around a middle value, is the measures of central tendency. The most three common measures of central tendency is the mean, median, and let's start with the mean. The mean is the sum divided by total number. I think all of us is familiar with the mean. Mean is the sum, collect all the data elements you have and divide them by the total number of those. We call it also the average. The mean is the most commonly used of all measures central tendency, but it have a problem, which is it's most sensitive to extreme score. What does this mean? I will give you example. If we have those figures 12, 15, 17, 13, 11, 19, 12, and 13. If we got the sum of them is 112. If I divided the 112 by their total number, because we have 8 numbers here, so the mean will become 14. I think all of us, we can do this one. We can calculate the mean. Sum divided by total number. So what's the problem of the mean? It's very sensitive to the extremes. I will put the same numbers, 12, 15, 17, 13, 11, 19, 12, but I changed only the last number, which is 13. I put 301. The mean now become the total, which is 400 multiplied by the total number, which is 8 numbers. So the mean now is 50. So as we changed extreme, we put a very far number, the mean will be changed very, very much. It changed from 14 to 50 because we changed only one number and put one extreme. So this is the problem of the, but still it's the most commonly used. Examples here for the mean, we have 5 infant have Apgar score of 7, 8, 8, 9, and 8. So if I want the mean, it will become 8. So generally speaking, the 5 infants have a very good clinical condition. Okay? Now I will tell you what's the extreme. If in the same given example, one infant was severely depressed and his Apgar score was 1, instead of 9, I remove this 9 and put 1, the mean will become 6.4. Can I say now the 5 infants are severely depressed because the mean is considering severely depressed? No. Now it's affected by extreme. The second one is the median, and the median is the middle score. Median means the middle score of the population you have. Give example of it. If we have 2 and 2 and 2 and 3, 4, 5, 7, 6, 6, 8, what would be the median? The median is the numbers in the middle. So we will leave, as you see here, 4 numbers before the median and the 4 numbers or 4 figures after the mean. So after the median, sorry. So the median here is 2 numbers, 4 and 5. How can I calculate the mean? I will get the sum of 4 plus 5, which is 9, divided over the 2. So our median here is 4.5 because my data elements are even in number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's even because they are 10. So I will get 2 in the middle. I will get the mean of the 2. It will give me the median of the whole population. But what if it's odd number? I will leave 4 before the median and the 4 after him. So our median here is 4. Again, if we have even number, we will have 2 numbers to become the median. So I have to get the sum of them divided by 2 to give me the median. But if I have odd number, it will be only 1 number in between, some figures up and some figures or data elements up and down. It will be only 1 number. This is the median. The median have a very good thing that it cannot be affected by the extremes. Okay, does not take into account the qualitative value of individual score. The same here, and we change it just only extreme. We put a very big number here. Still, 4 is the median. What's the mode? Mode is the most frequently occurrence number or figure or data elements. Something is repeated too much rather than others. If you are looking to do this example, you can find that 4 is repeated here, 6 is repeated also, 2 is repeated also. So what's the most frequent number repeated here in this one? I think it's very clear that 2 is repeated too much. 1, 2, 3, 4, 5, 6 times. It's repeated 6 times. So my mode is 2. The reader can easily determine that the mode is 2. The value of 2 was given 6 times, so a higher frequency than all other numbers. So my mode here is 2. We finished now the measures of central tendency. We have another example called the measures of variability. Measures of variability refer to how spread out of the group of scores, unlike the average, which is the mean, that they are spreading away from it. But the mean or average is spreading around central value. The 3 times, which is the range or standard deviation and the interpercentile information. But we here will discuss only most important range and standard deviation. What's the range? Range is the difference between highest and lowest value. If you have some numbers, get the bigger numbers, and the lower numbers, subtract them from each other, it will give you the range. For example, if we have 2 numbers here, 163, so our range is 37. And also it's very sensitive to extremes of values. What about standard deviation? is the statistical way to describe how much variation exists in a set of data or group or a process. Standard deviation is the most frequently used in statistics for measuring the degree of variability. If you want to know there is how much degree of variability in some statistical process, you have to use the standard deviation. Okay? Wilson in 1987 described the standard deviation as an average spread of a score or value around the mean. It's how much the data elements are spreading away or around the mean. What's deviation? Indicates how much each score is scattered from the mean. This is the deviation. The greater the spread of distribution, the greater the variability. As soon as we are spreading away from the mean, this means we have a lot of variability.